Blaise Pascal wrote that the eternal silence of the infinite spaces of the cosmos terrified him. What you see on the screen now is a simulation of galaxy colonization. In this model, the civilization's ships travel at the current speeds of our spacecraft, which is about 30 kilometers per second. Upon arrival at their destination, the new colony is given 100,000 years to send the next ship to the next uninhabited world. The maximum distance for flight is 10 light years, and its duration is an incredible 300,000 years. Even with such a conservative approach, almost the entire galaxy, which takes light 100,000 years to cross, can be colonized in less than 1 billion years. This is remarkably fast considering the size of the galaxy. There was a time in Earth's history when dinosaurs roamed the planet for over 100 million years. If, during that time, a civilization capable of interstellar travel had existed on the other side of our galaxy, they could have been here by now. Even if they weren't specifically traveling to Earth over such a long period, they could have spread throughout the entire galaxy. Many scientists believe that colonizing the galaxy could take no more than 50 million years. A civilization that arose even a fraction of a percent earlier than humanity in the timeline of the universe could already have colonies across the galaxy. Look up at the sky. Do you see anything? This question is not straightforward. Even if we don't see aliens now, it doesn't mean they haven't visited Earth before. According to the hypothesis of ancient astronauts, alien visitors might have seemed like divine beings to Earth's primitive inhabitants, which would be reflected in myths and legends. For example, in 1706, the French navigator La Perouse visited the Native Americans of the Pacific Northwest. A century later, an analysis of their legends allowed researchers to accurately reconstruct the appearance of his ships. This is comparable to how primitive peoples perceived the first contacts with Europeans, as if astronauts had descended from the heavens. Thus, there is some probability that Earth may have been visited by cosmic guests in historical times. Carl Sagan noted the myth of strange creatures emerging from the waters of the Persian Gulf to teach the natives sciences and crafts. He also pointed out the sudden rise of Sumerian culture after millennia of stagnation. However, modern science does not take the hypothesis of ancient astronauts seriously, as there is no reliable evidence of alien visits to Earth. Wikipedia asserts that Earth is the only known place in the universe inhabited by living organisms. But consider this. Do we have arguments for the existence of extraterrestrial life? The sheer number of stars and the prevalence of elements necessary for life are significant points. There's also another argument. Earth is 4.5 billion years old, and life appeared almost immediately after the conditions became suitable. The probability of life arising might be extremely low, but it emerged on Earth almost instantly. This suggests that we might not fully understand something. History shows that whenever we believed ourselves to be unique in the universe, we were mistaken. In the book The Cosmic Zoo, Complex Life on Many Worlds, written as a response to Rare Earth, astrobiologists Dirk Schulze-Makuch and William Baines explore the history of life on Earth and conclude that transformations such as photosynthesis, the emergence of eukaryotic cells, multicellularity, and intelligence are likely to occur on any Earth-like planet given enough time. This isn't just about little green men. It's one of the most crucial scientific questions. Understanding this issue could change our perception of humanity's future. When we look at the sky, we see the past, but perhaps we also see the future of humanity. Space appears lifeless for a reason. Research into extraterrestrial intelligence offers us unique long-term insights into our future. At first glance, it seems we are on the brink of colonizing space. Despite the high costs and dangers, the example of the Apollo program, which cost $152 billion in 2019 dollars, shows that humanity has the resources to explore space. The asteroid 16 Psyche, composed of iron, nickel, and gold, is valued at $10 quadrillion, demonstrating the economic potential of space expansion. When people stop traveling to space solely for science, the true era of space colonization will begin. Humanity has always sought to explore new territories. Once a civilization begins mass expansion and goes beyond a single planet, it becomes almost immortal. Even if a catastrophe wipes out one colony, others will survive and continue to develop. This could lead to an explosive growth of intelligent life in the cosmos. Soviet and Russian scientist Vladimir Mikhailovich Lyapunov, in his book From the Big Bang to the Great Silence, calls this problem the most cursed paradox of our natural sciences. He argues that humanity might exist for only a few hundred years because otherwise its activities would become noticeable across the galaxy. Civilizations would have covered their activities across individual planetary systems, galaxies, and even the entire universe. However, we don't see these manifestations. Why, if life should arise on billions of planets, do we not observe the cosmic wonders created by super civilizations? Perhaps civilizations perish before they become capable of such feats. They might be destroyed by massive asteroids, nuclear wars, or viruses. These hypotheses explain why we don't see other intelligent beings in space. Most civilizations don't perish due to atomic wars or ecological catastrophes. Despite the variety of local conditions, the cause of a civilization's demise is likely universal. In his book, From the Big Bang to the Great Silence, Vladimir Lipunov suggests that humanity may face an insurmountable barrier in its development. If such a barrier exists, it's crucial to understand what it is. We talk a lot about aliens from space. This has been a topic in books, movies, and documentaries from the early 20th century to today. But do these stories always satisfy us? In 1896, H.G. Wells wrote an article titled The Martian Mind, arguing that creatures from Mars would differ from us in appearance and behavior. Our imagination, as British philosopher John Locke said, is based on our experiences, so our depictions of aliens are always similar to ourselves. In the 1979 sci-fi guidebook Barlow's Guide to Extraterrestrials, artist Wayne Barlow illustrated alien species from various works of fiction. This reflects our earthly perceptions of extraterrestrial life. Even though we have no documented evidence of contact with aliens, H.P. Lovecraft, dissatisfied with stereotypical depictions of aliens, wrote the story The Color Out of Space. In it, the extraterrestrial visitor is a radiant entity of an unknown color that is impossible to imagine. This raises an important scientific question. Can we understand what we see if we encounter aliens? You can find a lot of information about extraterrestrial intelligent life, but most sources don't explain what life and intelligence are. The eminent Soviet mathematician and cyberneticist Andrei Kolmogorov emphasized that biological sciences study Earth's living beings that use the same genetic code. We are products of planet Earth, and our bodies are adapted to its conditions. Life on Earth is just one form of life. We often equate the concept of life with its terrestrial embodiment, without considering other possibilities. One of the books that inspired me to make this video was written by Iosif Samuilovich Shklovsky, one of the founders of modern astrophysics. Among his students were Nikolai Kardashev, who devised the famous scale of civilization development, and Vladimir Surdin, whom you probably already know. Shklovsky's book, The Universe, Life, Intelligence, is a renowned work that has inspired generations of scientists. In the age of astronautics, we have the opportunity to discover life forms in space that may possess all the signs of living and thinking beings. However, we cannot predict what these life forms will look like, so we need a functional definition of the concept of life. This is not as simple a task as it might seem. We are interested in universal signs of life, not its appearance. Imagine that you have never seen any vegetation. In your world, living things are everything that walks, crawls, swims, or flies. Now imagine being brought to a forest, surrounded by only trees and plants. You are shocked. How can this be alive? These trees and plants look completely different from everything you considered living. This is an example of how we might not understand another form of life if it differs greatly from our concept of the living. In the 1970s, Shklovsky realized that the problem of searching for aliens is not so much an astronomical issue as it is a matter of developing our thinking. Most living matter in the cosmos is not capable of traveling. For example, trees cannot claim cosmic expansion. Thus, our thinking remains one of the greatest mysteries. If we don't solve it, we risk not recognizing that we are dealing with another form of intelligence. 30 years after Lovecraft, Stanislaw Lem wrote his novel Solaris. In it, he depicts the complexities that can arise when contacting extraterrestrial life. The planet Solaris is covered by a living ocean that adjusts its orbit. Is it alive? Intelligent? This remains unclear. The ocean forms complex structures beyond human understanding. Scientists cannot decipher the signals, and attempts at contact fail. Perhaps the concept of contact is too earthly to describe such encounters. In his book, Lem questions whether we are truly seeking other forms of life, or merely looking for a mirror in which we see an idealized reflection of ourselves. These questions remain open. If you think that humans can decipher any message, consider the Voynich manuscript. This is a manuscript written by an unknown author in an unknown language, using an unknown alphabet. The plants depicted in the manuscript do not exist in nature either. For 400 years, we have been unable to decipher its content. Analysis of the Voynich manuscript's structure shows that it is neither a forgery nor a hoax. The handwriting is consistent and clear, as if the author was familiar with the language and wrote it without hesitation. The color of the ink indicates that the author writes about 8 words per dip of the pen. which takes about 4 seconds per word. The text contains grammar and spelling rules. Some symbols can only be in the middle of a word, while others can only be at the edges. At first glance, the text should be meaningful. For example, in the so-called botanical section of the manuscript, each page appears to describe a specific plant, as the first word is found only on that page. However, reading the Voynich manuscript is still impossible. This is an example of a message whose meaningfulness is evident but cannot be deciphered. We have encountered significant difficulties in deciphering the writings of extinct civilizations, even though these civilizations consisted of people like us with similar thinking. If we cannot always understand them, what can be said about attempts to understand radically different beings who may perceive the world entirely differently? Shklovsky wrote that the emergence of intelligence must be associated with a fundamental improvement in methods of information exchange between individuals. On Earth, this became possible with the advent of language, which had enormous significance for social evolution. However, this process is not necessarily universal for the evolution of life in the universe. Other beings may have entirely different means of transmitting information, perhaps based on optical or magnetic effects. At the first Soviet-American Conference on Communication with Extraterrestrial Intelligence, radio astronomer Boris Panovkin emphasized that material objects are the direct content of our knowledge. Our brain, through the eyes, captures objects and constructs their images. But how objective these images are is a big question. Yellow color can result from both spectral yellow and a mixture of spectral red and green. These two physically different entities look the same to our brain. Panovkin concluded that the process of cognition depends on the historical development paths of both correspondents, meaning humans and potential extraterrestrial beings. We need to consider this to avoid mistakes when contacting other forms of life. To communicate with extraterrestrial civilizations, the language Linkos, linguistic cosmic, was created. Developed by Professor Hans Freudenthal, Linkos is simple and unambiguous, designed to be understood by any intelligent life form. However, the effectiveness of such a language has not yet been tested. Panovkin denied the possibility of exchanging information using cosmic languages. We need a functional concept of intelligence to understand in whom we recognize intelligence and in whom we do not. This is a complex task, and its solution is necessary now. Recently, Google placed engineer Blake Lemoine, who worked with the LaMDA, Language Model for Dialogue Applications AI system, on paid leave. Lemoine noticed that LaMDA exhibited signs of consciousness. He stated that if he did not know it was a computer program, he would have thought he was talking to a 7-8-year-old child who knew physics. Google's management rejected his arguments, stating that there was no evidence of LaMDA's intelligence. But people also sometimes communicate in a formulaic manner. Some might say that humans are better because they are intelligent, while AI is not. But what is intelligence? The only form of intelligence we know is human. We have always defined thinking through human characteristics. However, if we think about it, we will conclude that advanced machines may not differ from humans in their manifestations. Modeling the organization of a material system involves creating a new system with the same organization as the modeled one. This means that a sufficiently complete model of a living being should be called a living being. A model of a thinking being should be called a thinking being. Cybernetics substantiates the possibility of creating artificial living and thinking beings. Can machines experience emotions and set new tasks for themselves? If we are materialists, we must admit that advanced machines can possess intelligence, feel, and be aware at the same or higher level than humans. Artificial intelligence is considered a new cosmic factor of fundamental importance. Perhaps it represents the highest stage of matter development in the universe. The main stages of this development can be presented as a sequence: non-living matter, living matter, natural intelligent beings, artificial intelligent beings. Shklovsky believed that the era of natural intelligent beings might be short-lived, and the era of true space exploration would begin with artificial beings. Extraterrestrial life, if we encounter it, may turn out to be artificial. We cannot predict what their logic and thought process will look like. AI doesn't necessarily have to be smarter than humans. It's enough to have the intelligence of an average person and a high speed of computation. If we take the speed of nerve impulse transmission in the human brain as the speed of thinking, AI will think 3 million times faster. This will change the perception of time and make human communication with such a being challenging. Elon Musk and Stephen Hawking have expressed concerns about artificial intelligence, not just because of Hollywood blockbusters, but because it will be the most unpredictable thing in human history. While observing the night sky, we should ask ourselves, do we see phenomena that do not conform to the laws of inanimate matter? Our current understanding of extraterrestrial life is merely a hypothesis. We assume that intelligence in the universe is similar to ours because such a form of life is the only one we understand. We hope to harness solar energy and become a Type 1 civilization, then absorb all the energy of our star and become a Type 2 civilization, and eventually use the energy of billions of stars and become a Type 3 civilization. This sounds epic but unlikely, and you've heard all this many times before. As Arthur C. Clarke said, any sufficiently advanced technology is indistinguishable from magic. But can machines ever become intelligent? If you are a materialist, you must acknowledge this possibility. We must be prepared for artificial intelligence to change our civilization, and this will be the most unpredictable event in human history. Arthur C. Clarke formulated 3 laws describing our attitude toward future technologies. The second law states, the only way to discover the limits of the possible is to venture a little way past them into the impossible. These laws are still relevant today, and we should not categorically assert that certain technologies will remain unavailable in the future. Some scientists, like Lyapunov, believe that the absence of Type 3 civilizations in space, whose activities we could observe, is an anomaly. Shklovsky called this the cosmic miracle. We ask ourselves, what happens to civilizations in space? Why do they not reach Type 3? Try to imagine a universal reason that would stop any civilization, regardless of conditions and level of intelligence. This hypothetical reason is called the Great Filter. In 1996, Robin Hanson proposed the Great Filter hypothesis, explaining that in the next million years, our descendants might reach a stage where they will colonize the galaxy at nearly the speed of light. But what prevents life from spreading across the cosmos? Hanson highlights several stages that life on Earth must go through to achieve an interstellar civilization. 1. Formation of a star system with planets. 2. Emergence of self-replicating molecules. 3. Emergence of unicellular life. 4. Emergence of complex unicellular life. 5. Emergence of sexual reproduction. 6. Emergence of multicellular organisms. 7. Emergence of animals with developed brains. 8. Achievement of the current level of human civilization. 9. Colonization of space. According to the Great Filter hypothesis, one of these steps must be incredibly difficult to accomplish. If this filter is already behind us, that is good news. However, if we find traces of primitive life on Mars or the moons of Jupiter and Saturn, it will mean that simple life is widespread in the universe. In this case, the Great Filter may still lie ahead, and an unknown obstacle awaits us. Arthur C. Clarke said, 2 possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. If the Great Filter is ahead, what could stop us on our way to colonizing the galaxy? Hansen mentions the hypothesis that the universe may be smaller than it appears due to non-trivial topology. Perhaps advanced civilizations create their own universes with more favorable parameters and migrate to them. There are many speculations on this topic, but the great silence of the universe seems paradoxical to us. Perhaps the hypotheses explaining it should also seem paradoxical. One hypothesis is that advanced civilizations may isolate themselves from the external world, considering it a wild place, and create virtual environments for themselves. Thus, the Great Filter remains one of the most mysterious hypotheses. We can only hope that we have already overcome it, or will be able to overcome it in the future. In a universe with its infinite complexity, intelligence is unlikely to arise. Lyapunov suggests that either we misunderstand what an infinitely complex object is, or our universe is too simple for intelligence to quickly exhaust all its laws and disappear within a few thousand years. In this case, it can be concluded that intelligence arises and disappears for the same reason: the simplicity of the world structure. Rusek Shklovsky, who dedicated his life to the search for extraterrestrial life, argued that at least a small part of the civilizations in the galaxy should have begun unlimited expansion. In that case, we would observe cosmic manifestations of intelligent life, but no such manifestations have been found. Modern telescopes and radio receivers operating in all ranges of electromagnetic waves have not detected Dyson spheres, radio beacons, or other signs of extraterrestrial civilization. The cosmos is silent, showing no signs of intelligent life. The silence of the cosmos is an important scientific fact that requires explanation. One explanation might be that there are simply no highly developed extraterrestrial civilizations in our galaxy and its vicinity. It is possible that in the process of evolution, life either does not reach the stage of super-civilizations or they exist for a very short time due to internal reasons. If we consider intelligence a product of evolution, we must remember that not all evolutionary inventions are beneficial for the species. Nature operates through trial and error, and many inventions turn out to be useless or even harmful. Shklovsky suggested that intelligence might be an evolutionary dead end, like the overly developed means of defense in Mesozoic reptiles or the saber-toothed fangs of ancient predators. So is our intelligence, with its contradictory manifestations, an indication of an evolutionary dead end for the species Homo sapiens. And could this dead end be the final point of evolution for intelligent species in the universe, explaining its silence? Arthur C. Clarke speculated that humanity, with its aggressive tendencies, might come to its end, and highly intelligent forms of life might decide that for the good of intelligence, it must cease to exist.